Okay, so I just finished aerating this fluid. This is an OW40 Euro spec Mobile 1 fluid. And we're going to show the compressibility of the fluid in this space. And it's going to demonstrate why you guys are losing power due to aeration. Okay, so Boundary has a couple of products that fight aeration in the oil. And one of them is the billet backplate, which reduces the induction of air across the back of that backplate. And then the other one is the vane ported or dual rotor setup, which has these slits in the side. And what that does is it increases the amount of basically flow area that allows that fluid to go into the gear. And so by doing that, we reduce the flow velocity and we reduce the pressure drop whenever that pump's operating. So here I'm going to show you how compressible aerated oil is. So I'm just going to give this a squeeze. So you can see, like, that's a lot of compressibility. And what that means is, so if you think of this as being like one, so this is perfect oil, and then me squeezing down on it. So we're losing about 15 to 20% of our flow volume at 100 PSI because the oil is aerated, okay? And what that means is that if your pressure gauge is at 100 PSI and you start to get some of this aerated oil into your engine, that pressure can drop to 85 PSI. It could drop to 80 PSI. And sometimes if the sump actually becomes uncovered and you get air into the engine, it can get really, really bad. So I'm going to show you what happens whenever you get air into the motor. Okay, so let's say that we're like this, where we're sucking up 50% air and we're sucking up 50% oil. Okay, so now, okay, let me actually induct some air. There we go. So now let's look at how compressible it is. So in this case, like when I get down to 100 PSI, we've lost 60%, 70% of our oil pressure. So this is what's actually causing pressure drop in the engine. So a combination of unflat backplates, backplates not being properly ported so that they allow the fluid to go in there easily, gears that are spinning too fast without enough flow area so that you're choking off the flow. That causes boiling of the fluid, that causes air bubbles, it causes cavitation at the high-speed tips. All those things together create this bubble matrix in the oil, and all that stuff's compressible. And what it's coming out as is pressure loss, and particularly at high RPM. So the Boundary product line is kind of divided into two different sections. One is volume, which is what the dual rotor's for, and the other one is oil quality. So oil quality items are billet backplates, they're extra seals, they're extra flow enhancements, all those things, so that the oil that's actually being delivered to your motor is free of these bubbles that are compressible. Okay, so what we're looking at here is a graph of bad oil quality. So we see the engine go up, we see the pressure go up, and then it limits on the relief valve, and then it starts to go back down as it climbs up to its peak. A couple things could be causing that. It could be a flaw in the backplate, allowing air to come in from the backplate side. It could be pressure loss between the pump and the block. It could be pressure loss from the pickup tube being too small, or blockage of the pickup tube, or it could just be bad pump clearances, that you're not getting a good pump because of the pump not being tight enough. So, but this is commonly what we see. This is what I get questions about whenever customers call in asking about our product. They ask, will it fix this? And we do have products that will help out with these types of pressure drops. That's going to be your dual rotor, it's going to be your vane ported Martinware, and it's going to be the billet backplate. Those are the three that you need to look after for pressure drops at high RPM.